Welcome to another past paper video. Today's paper is June 23. This is paper 1 variant 11, and I'm going to be solving this for you today. Let's start solving it then. Question number 1 says solve the equation. This is a trigonometry question. I think that's relatively simple. So I put in my identity for sine theta plus sine theta over cos theta equals to 0. And then I can say that I can take a common denominator. So I have cos theta in the denominator, and I have 4 sine theta cos theta plus sine theta equals to 0. This cross multiplies and gets done with. 4 sine theta cos theta plus sine theta equals to 0, since sine theta can come out common, and I can say that this is 4 cos theta plus 1 equals to 0. So either sine theta equals to 0 or 4 cos theta plus 1 equals to 0. Now this is from 0 to 180, so I just have quadrant 1 and 2, quadrant 1 and quadrant 2. Alpha equals to sine inverse of 0, which is 0 itself. I can say that quadrant 1 is 0, but not included because it's outside. You see 0 and 180 are not included here. They are greater than or less than, so not included. Quadrant 2 is 180 minus 0, which is also not included. So these two will not be part of your final answers. Remember that giving me extra answers will lead to a deduction in mark. Let me see if that is the case in the marking scheme. Yeah, let's quickly check. It says ignore answers outside 0 and 180. Yeah, okay. There might be a deduction for 1 mark if you give me extra answers. So cos theta equals to minus 1/4. That's in quadrant number 2. So alpha equals to cos inverse of 1/4. Let's quickly do that on our calculator. My calculator should be in degrees right now. And divide by 4. That gives me 75.5. And quadrant 2 will be 180 minus 75.5. That's 104.5. Okay, and that is my final answer. Moving on to question number 2. Question number 2 says find the first 3 terms in the expansion. So I know that term number 1 is nc0 a power n minus 0 and b power 0. Term number 2 is nc1 2 power 4 minus 1 3x power 1. Term number 3 is 4c2 2 power 4 minus 2 and 3x power 2. So the first 3 terms should be 2 power 4 is 16, 4 into 8 into 3. That should give me 96x, and 4c2 is I think 12. 4c2 is 6 into 4 into 9 gives me 216x squared. So the first 3 terms are 16 plus 96x plus 216x squared. Whereas the first 3 terms in the expansion and ascending powers of this, so that's another expansion. 5c0, 1 power 5 minus 0, minus 2x power 0. So that gives me 1. 5c1, 1 power 5 minus 1, minus 2x power 1. That gives me 5 into minus 10x. And term number 3, 5c2, 1 power 5 minus 2, 2x power 2. So that's 4 into 10, 40. With a plus, yes. 1 minus 10x plus 40x squared. Let's see what the last one says. It says, hence find the coefficient of this of x squared in the expansion. Okay, so I know that I need to write both my expansions. So 16 plus 96x plus 216x squared. That's the expansion of the first bracket. And I know that this expansion is continuing, so I should write dot dot dot. and 1 minus 10x plus 40x squared. Okay, so I need terms in x squared. Okay, this was 96x plus. So I know that 96x multiplied by this x term will give me a square, but before that, this term will also give me a square. So 16 into 40x squared, then 96x into minus 10x, and 216x squared into this, into 1. So what do I get when I add all of these up? 16 into 40 plus minus 960 plus 216. I get minus 104x squared. I am just asking you for the coefficient, so my answer is minus 104. Moving on to question number 3, it says y equals to g of x and I equals to f of x. I see two functions there. This seems like a question on transformations. I see that it was stretched like that and it was also sort of moved. Okay, describe fully the sequence of two transformations which transform this into g of x. So I know that there's a stretch involved. The way of figuring out a stretch factor is to see the length of the vertical parts. Okay, so this had a length of 6 units. This has a length of 4 units. Okay, that seems a little odd. Oh, okay, my bad, my bad. This has a length of 8 units. Okay, and that has a length of 4 units. Because I wasn't counting those bottom parts. Okay, so then in that case, what I can say is that there is a stretch factor of 2 involved. Okay, and when there's a stretch factor of 2, I can say that it's a vertical stretch with factor 2. Now, what I've got to do is, in order to figure out how much it has translated, what I'll have to do is I'll have to draw the stretch for you. So this point is at 3, it's going to go at 6. This point is at 3, it's also going to go at 6. I can right now see this translation emerging, but I'm going to go on and translate. So this was at minus 1. This one is at minus 3. So this graph looks something like this. Okay. Minus 2, sorry, minus 2. Okay. And this one was at minus 3, so it's at minus 6 now. So that's the graph that you see on the left as well. Do you see the translation now? Do you see that this point has moved backwards? And how much has it moved backwards? It's 3, 4, 5, 6, 6 units backwards. So translation with vector, well, it followed by with vector minus 6, 0. Okay. Okay, question number 4 is circular measure. Let's look in this question then. It says the diagram shows a sector ABC with center A and radius is. The area of the sector is 16 pi over 3. The point D lies on the arc ABC. Find the perimeter of the segment BCD. So if I'm given the area, I can quickly go on and figure out theta for you. Area of sector is half r square theta. So 16 over 3 pi equals to half 8 square theta. Okay, so that's 16 pi over 3 into 2 divided by 64 equals to theta. Let's do that on a calculator. 16 into 2 divided by 3 into 64. And it gives me pi over 6. So once I have that, what I can then go on and do is I can find out the arc length. and say that's r theta, and that's 8 into pi over 6. That gives me 4 pi over 3. In order to find this side, I'm going to use the cosine rule. I'm going to say that BC squared. Okay, let me just confirm my answers. Yeah, okay. So BC squared equals to 8 squared plus 8 squared minus 2 into 8 into 8 into cos of pi over 6. So 8 squared plus 8 squared minus 2 into 8 into 8 into cos of k in this case. I am getting root of answer BC as 4.14. So total perimeter 4 pi over 3 plus 4.14. So 8.33. That is the correct answer. Let's move on to the next question. It says a line with equation kx minus k, where k is a positive constant, is a tangent to the curve with this. Okay, so questions relating to the tangent can either be about differentiation or quadratics, but in this case I'm going to go with quadratics, and the reason is that I have an unknown in the question, so that means I'm solving a quadratic equation. Okay, so I will first solve them simultaneously. I'm going to equate the two, and then whatever equation I get, I'm going to say that this equation is going to have one real root because it's a tangent. So 2kx equals to minus 1. So 2kx square minus 2kx plus 1. That's the result of solving simultaneously. And I'm going to pull out ABC and say that b square minus 4ac equals to 0. So minus 2k squared minus 4 times 2k times 1 equals to 0. So 4k squared minus 8k equals to 0. Putting out from, I'm just going to say that there are two roots from my calculator. K is 0 and k is 2. Yeah, okay, k should be 2. So I have k as 0. It says k is a positive constant, so it's only k equals to 2. Okay, then and the coordinates of the point where the tangent meets the curve. So I can say that now that's the curve that I'm talking about, and that's the tangent that I'm talking about. So I'm going to again solve them simultaneously, although I could have just picked up this equation and inserted k. So I could have done that too. It's absolutely fine if you're doing this. Okay, again putting this on my calculator on the exam, make sure that you at least show the quadratic formula so that you don't get marks deducted for missing out on the method. Although the examiner is now aware that you can solve all of this on a calculator. So it's coming out as x is half. Okay, coordinates. So I need the y coordinate as well. Minus 1. So half comma minus 1. Check if that has the correct answer. Yeah, that is indeed the correct answer. KS2. Okay. This is the first three terms of an arithmetic progression are p square over 6, 2p minus 6, and p, given that the common difference of the progression is not 0. So arithmetic progressions have a common difference, so the difference between these two will be equals to the difference between these two. So 2p minus 6 minus p square over 6 should be equals to p minus 2p plus 6. Okay. 12p minus 36 minus p squared and divided by 6. I've taken a common denominator, so I get minus p plus 6 here. Then I cross multiply. Let's move everything to one side. It says p square equals minus 6p minus 12p plus 36 plus 36. P square minus 18p plus 72. Let's see if we get the correct answers from this. 1 minus 18 and 72. I'm getting 12 and 6. Yes, 12 and 6. Find the value of p. Okay, so one of these will probably give me a common difference of 0. Let's see which one that is. If I calculate the first three terms using, I can figure out in another way as well. I can just say that 12 square over 6, 2 into 12 minus 6 and 12. Okay, so 144 over 6 is 24, and 18 and 12. So this looks like the correct answer. If I put in p as 6, it's going to give me 6 square over 6, 2 into 6 minus 6, and 6 itself. So it's going to be a progression that says goes like 6, 6, and 6. So this is not arithmetic. Therefore, p cannot be 6. P can just be 12. Okay. Using this value, find the sum to infinity of the geometric progressions with the first two terms. Okay. So I'm going to use my value for p and figure out what the terms that I'm talking about. I'm talking about the terms 24 and 18. Now, these are the first two terms of a geometric progression. So it must have an r, this term 2 divided by term 1, which is 3 over 4. Yeah. Sum to infinity is a over 1 minus r. So 24 over 1 minus 3/4. Again, let's go back and check if our answers are correct. Yes, 12 only, and this is also correct, which is 96. Question 7, which says a curve has equation this. State the greatest and least possible values of y. So I can just do this on my calculator. I don't really need to do this manually. I'm just going to go to my calculator and program this on my calculator and show you the greatest and least values. In any case, I have to later go on sketch the curve as well. So I'm going to go to menu, and I'm going to go to table, type 2 plus 3 sine half x. Now I know that this is in radians, but I find it difficult to draw it in radians. So I'm going to draw it in degrees. I'm going to say that it starts from 0, and this is 4 pi. So this is 720. Okay, I hope everybody understands that. 2 pi is 360 and 4 pi is 720. And the step is also going to change. By default, the step of sine x is 90 degrees. So this is half x, which means that the step is doubled. I'm going to put a step of 180. Now I can see from my values that I have the maximum and minimum values. I can say that the greatest and least values of y are minus 1 and 5. So greatest is 5 and least is minus 1. I think that's the easy way of solving this question. There are other ways of solving it as well if you've learned it in a different way. I'll also find this easy to sketch now. I can just draw my axis 1, 2, 3, 4, 5. I strongly recommend that you draw it, that you mark this axis with the scale possibly, so that you don't have this sorry uh, weird curve ending up with sort of differing amplitudes. Okay, so that's the first point that I'm going to mark, 0, 2, and 180 is pi, which is 5, and then 2 pi 360 is again 2, I'm going to mark that here. Then 540 is 3 pi, which is minus 1. I think this axis is lower than smaller than I want it to be. The points have to be larger. And then 4 pi is again 2. Going to go here. Okay, so the curve is going to look like that. Okay, state the number of solutions of the equation this 5 minus 2x. So I understand that these two equations have been solved simultaneously. I have one of these curves on the axis above. Can I draw the other one as well? I know that it starts at 5. Okay, I'm going to use my pencil and then erase it later on the exam, because the question doesn't say that I have to draw this on the curve. If I draw this here and I try to draw this line. Now it's difficult to draw this line, okay, because my axis is not standard 1, 2, 3, 4, 5. It's going up to 4 pi. Can I calculate the end point though? Can I insert 4 pi and say that this value is basically minus 20 somewhere? Okay, so this line has to go to minus 20. So this line is probably going something like that. It's a very low point. So at 4 pi, it's going something like that. So I can say that there has to be only one solution. Why? Because there's only going to be one intersection point between the line and the curve. Okay, moving on to the next question. This is functions. Okay, so this question says that function f and g are defined as follows, where a and b are constants, given that f of 7 equals to 5 over 2. And gf of 5 equals to 4. Find the values of a and b. I think f of 7 is easy to do. I can just say that the y value is 5 over 2 and the x value is 7. Okay, okay, I can solve this. I can take 1 to the other side. 5 over 2 minus 1 will give me 3 over 2. I think I'm going to run out of space on this one, so I'm just going to write it here. 2a over 7 minus a. Then I can cross multiply and say 21 minus 3a equals to 4a, and 21 equals to 7a, and a equals to 3. Then gf of 5 equals to 4. So first I'll construct gf of x. Gf of x is basically b into 1 plus 2a over x minus a minus 2. Now x is 5 and y is 4. So I'm going to write 4b, x is 5, and I've already found out a. I'm going to say that 1 plus 2 times 3, and then 5 minus 3. That's 6 equals to b into 1 plus 6 over 2, 3, 4b. So b is 1.5. Let's verify if that is the correct answer. Yes, that indeed is the correct answer. Then for 1 mark, it says straight. For the rest of the question, you should use the value of a equals to 3. Find the domain of f inverse. So the domain of the inverse will be the range of the original function. Now the original function is something like this. It's f of x equals to 1 plus 2, 1 plus 6 over x minus 3. Now for rational functions, there's no shortcut. You will have to sketch the graph at some point. So a typical graph of 1 over x looks like this. Okay, it has asymptotes at both axes, and it's going to infinity on both axes. Now what I see from my graph is that if I think about transformations, this graph has moved 1 unit up and it's moved 3 units to the right as well. So what I can sort of predict is that there are going to be new asymptotes here, and the graph won't look like this anymore. It's going to look something like this. It's going to have an asymptote at 3 and it's moved 1 unit up. So the graph is going to look something like this. Since the domain is just x is greater than a or x is greater than 3, I'm going to say that at 3 it goes to infinity. That is what I know for sure. So it's going up to infinity. I'm writing down the domain, so it's going up to infinity. Is there a bottom value? Yes, there is a bottom value. There is 1. This is technically the range of the original function, which I've written as the domain of the inverse. The range is from 1 to infinity, so that's from 1 to infinity. You can skip the infinity and just say that x is greater than 1 for the domain of the inverse. Then I have to find the inverse, and that's, I think, simple. And just go on and do this function simply. I'm going to say that 6 over x minus 3 equals to 1 plus y. 6 over 1 plus y equals to x minus 3, and 6 over 1 plus y plus 3 equals to x. So that's f inverse of x, 6 over 1 plus x plus 3. Now you don't have to kill yourself over this range, even if you're unable to do it. It's just 1 mark on the exam right now. So it's best to just move on if you're unable to predict that, but you should know what happens to the range when you have these transformations applying on rational functions. Rational functions are the most difficult to handle. Okay, question number 9 is on, again, differentiation now. Water is poured into a tank at a constant rate of 5000 cm cube per minute per second. This is basically rate of change that we do in further differentiation. So water is coming in, so I'm going to write dv over dt is equals to 500 t seconds after filling, when the depth of the water in the tank is h. The volume v of water is given by this. Okay, that's a complicated expression. Find the rate at which h is increasing, so dh over dt. So what I'm going to do is I'm going to first calculate dv over dh. It's going to be 12 over 3, 25 plus h squared into 1, 4. That's dv over dh. Can I construct a chain rule for myself? $500, and dh over dt is what I'm trying to find when h equals to 10. So dh over dt and h equals to 10. Try to see if we get the correct answer on this one. Okay, on the previous question, I think I may have gotten sign wrong. This has to be minus. This has to be minus. This has to be minus. And there's a minus in the numerator as well. Okay, so my bad, I got that wrong. I didn't check before. Okay, let's check if we've gotten this right. Just doing my calculations again. Zero 0.102. Yeah, that is correct. cm per second. At another instant, the rate at which h is increasing, so dh over dt is 0.075. Find the value of v at this instant. So let's go back to our chain rule and think about it that way. I think I have to find out h first and then put it into the expression for v. So the expression that I gotten is 4 into 25 plus h whole square equals to 500 over dh over dt. So I'm just going to use 0.075 and see if I can solve for h this time. Divide by 4 gives me 25 plus h whole square equals to 5000 over 3. Go to 5000 over 3 gives me 25 plus h equals to 50 root 6 over 3, and 25 plus h equals to minus 50 root 6 over 3. Okay, 25 plus answer gives me h as 65.8, and 25 minus answer gives me minus 15.8, so that's can't be possible. This one is the right answer. What is the value of v at this point? I'm going to pick up my formula for V, 4 over 3, 25 plus h whole cube plus h whole cube minus 62500 over 3. It's a very complicated sort of expression. Let's put that on a calculator as it is. Let's not meddle with the numbers. Let's put an extra decimal here so that we don't get our calculations wrong. It's basically 825. Okay, let's put that as 825. Okay, 25 plus 6.65.825 cubed into 4 divided by 3 minus 62500 divided by 3. Um, I'm getting a very large answer. I may have made a mistake somewhere. Let's check. Oh, my bad. I've done the calculations wrong. It's 15.8. And this one is the negative sign, so I'm going to erase that. Terrible calculation there. 8. Yeah, 825. This one is not possible. Okay, let's calculate that again then. 4 over 3, 25 plus 15.8 power 3 minus 62500 over 3 gives me 69889.6. If I were to round this to three significant figures, that would give me this centimeter cube. Okay, so this is a question on integration. I see that it says find the exact volume generated. The diagram shows the curve this in parts of the line x1 and y1. The curve passes through the points this and that. If I'm rotating about the x-axis, I need this point. This will serve as my limit. I'm going to say that pi 1 to 1.5. I'm going to write above squared minus below squared, and that's how I usually integrate. Okay, what is above? It's the curve that is above, so I'm going to write 4 over 2x minus 1 whole squared. And what's below? This is the line that's below. It's cutting off the curve, so the shaded area is basically trapped between the line and the curve. This has basically come in as a limit, so I don't need to worry about that line anymore. So this is going to be 1 squared, and this is also squared. Okay, and then I'm going to say that 16 to x minus 1 power minus 4. I still haven't integrated that. I'm going to keep it as it is. Now I'm going to integrate and say that this is 2x power minus 1 power minus 3 over minus 3 into 2. And this integrates to x, and I have the limits 1 and 1.5. Okay, then I can plug in my limits and say that I have 1.5 minus 1 power minus 3 over minus 6 minus 1.5 and minus 16, 2 into 1 minus 1 power minus 3 over minus 6 minus 1. Let's see if we get the correct answer. It's a complicated expression there. Okay, that's coming out as minus 11 over 6. Let's see what the other one comes out as. That's coming out as minus 11 over 3. So 11 over 3 minus 11 over 6. So it's 11 over 6, and there's a pi outside, so that I get pi. Let's check if that is the correct answer. Yes, that is indeed the correct answer. Then it says in part B, a triangle is formed from the tangent to the curve at B. The tangent drawn, There isn't a tangent drawn. Let's draw that then. Um, Curve the normal to the curve at B. From the tangent to the curve at B, the normal to the curve at B, and the x-axis. Okay, so there's a normal as well. Okay, so it's probably just between this, all of this. Since it says triangle, I have to make sure it's a triangle, not a trapezium. Then my tangent might be a little off, but it's okay. What do I need to find? Find the area of this triangle. So it's a long question. So first I'll have to differentiate this. I know that this is a differentiation question, so let's just take it up. I have 2x minus 1 squared minus 1. Okay, so dy by dx will be minus 8, 2x minus 1 power minus 3 into 2. So minus 16, 2x minus 1 power minus 3. Now what is the point B? The point B is 1.5 comma 1. So I'm going to say that dy by dx at x equals to 1.5 is minus 16 into 3 minus 1 power minus 3. That should give me 2, I think. Minus 2. So that's gradient of tangent. What is the equation of the tangent? 3 over 2 comma 1. So y minus 1 equals to minus 2x plus 3. Y equals to minus 2x plus 4. What point do I need? I need the point on the x-axis. So I'm going to put in y as 0. Okay, so when I put in y as 0, I get x as 2. So this is 2. This distance is 2. Actually, I don't need anything else. I can just say that this is the height of the triangle. That's 1. So this is half base into height. I don't need to consider the perpendicular or the normal for that matter. It's a shortcut. Area is half base into height. So what is the height? Okay, I can't be absolutely sure that this was touching at 0. Oh, okay, I need the normal then. Let's just find the normal of normal. Half and y minus y1 mx minus x1. So that's 2y minus 2 equals to x minus 3 over 2. If I can just find the x intercept of this line as well, so that's 2, 0, x plus half. So x equals to minus half. So this line is actually a little to the left. And since I wasn't sure, I had drawn it like that. Let's draw that in the proper way that it's supposed to be drawn so that I can see. So this axis will extend and I will have it at minus half. So then I can say that the base is 2 plus half, that is 2.5. So I'm going to say that area is half base into height. My base is this entire thing from this to this point. And I can then quickly go on and say that the area is 5 over 4. Okay, since it's had normal, I should have used it. That was a silly mistake in the middle. Okay, let's go on to question number 11. It says the equation of the curve is this, where a is a positive. The curve has a stationary value at a comma minus 15. Find the value of a. So when I have a stationary value, I can say that uh, at this point dy over dx will be 0. So 6a squared minus 24a is either 0 or is 4 from my calculator. Okay, can't be 0 because it's positive, so is 4. Determine the nature of the stationary point. So I'm going to differentiate this again. Dy over dx is 6x squared minus 30x plus 6a. Double differential is 12x minus 30 at a, so 4. Positive, therefore minimum. I hope that's the correct answer. Yeah. Find the equation of the curve. So dy over dx is 6x squared minus 30x plus 6 times 4. I think that's an easy question. You integrate, you get y equals to 6x cubed over 3 minus 30x squared over 2 plus 24x plus c. So y equals to 2x cubed minus 15x squared plus 24x plus c. Then you use the coordinates of a comma minus 15, so 4 comma minus 15 to find out the value of c. Equals to 1. Y equals to 2x cubed minus 15x squared plus 24x plus 1. Find the coordinates of any of the stationary points on the curve. I think that's possible. 6x squared minus 30x plus 24. That was dy by dx. I'm equating that again. I think x squared minus 5x plus 4. So I think there's another stationary point at 1. So I'm going to use that 1 and see if I've gotten the equation of the function correct. Yeah, I've gotten the equation correct. So 2 times 1 cubed minus 15 times 1 squared plus 24 times 1 plus 1. Y equals to 12. So 1 comma 12 is my final answer for the other stationary point on the curve. Okay, question number 12 looks like a question on circles, so it's a little complicated and also has a lot of parts. So let's quickly get done with that, and that should bring us to the end of the exam. The diagram shows a circle with center O2 and radius 10 and the tangent to the circle at the point A with coordinates 6, 10. It also shows the second circle Q. Okay, this one has a center at 0, 2. At 6, 10. It also shows the second circle Q with center P, Q with center at the point where this tangent meets the y-axis and with radius, this has a radius of 10. Okay, and this one has a radius, this is the center of the circle and it has a radius of 5 root 5 over 2. Okay, write down the equation of the circle P. I think that's relatively simple. X minus 0 whole square, y minus 2 whole square equals to 100. So x squared plus y minus 2 whole squared equals to 100. Okay. Find the equation of the tangent to the circle at P. I think that's also simple. I have the coordinates of A, and I'm going to say that A to the center of the first circle will be a line that will have a gradient. So I'm basically calculating the gradient of that line, 10 minus 2 over 6 minus 0. That's 8 over 6. That's 4 over 3. I will take a negative reciprocal of that to make it perpendicular, I know that the radius and tangent have to be perpendicular. That's what I'm counting on. So minus 3 over 4. I'm going to put in y minus 6 comma 10. y1 m x minus x1. So 4y minus 40 equals to minus 3x plus 18. 4y equals to minus 3x plus 58. A little awkward, so let's just check our answers before we go any further. 58 over 4 should be 29 over 2. Yeah, okay. So that's fine. Find the equation of the circle Q and hence verify that the y-coordinate of both the points of intersection of the two circles are 11. Okay, first let's find the equation of the other circle. I'm going to say that I need to find this point, so I'm going to find the y-intercept of that line. The y-intercept of that line is simple, minus 3 times 0 plus 58, y equals to 29 over 2. So I'm getting an equation that goes like x, since this point is the center of the other circle, I'm going to say that this has the coordinate 0 comma 29 over 2. And I'm going to make an equation x minus 0 whole square plus y minus 29 over 2 whole square equals to 5 root 5 over 2 whole square as well. Okay, 5 root 5 over 2, yeah. Okay, so I get an equation that says x square plus y minus 29 over 2 whole square equals to 5 root 5. I think that's 125 over 4. Okay, the other equation that I had for the previous circle was x minus 0 whole square, x square plus y minus 2. Oh, I've done that. Okay, x square plus y minus 2 whole square equals to 100. So what I can do is I can solve this simultaneously and take this to the other side, create a substitution, say that 100 minus y minus 2 whole square. So 100 minus y minus 2 whole square plus y minus 29 over 2 whole square equals to 125 over 4. Let's try to quickly solve that. I get 100 minus y square minus 2y plus 4 plus y square minus 29y plus 29 over 2 whole square. Okay, let's write it like that only. I know that I'll have to gather the numbers. 100 minus y square plus 2y minus 4 plus y square minus 29y plus 29 over 2 whole square equals to 125 over 4. I can see y square is cancelling out. I can see minus 27y. And so let's gather the other terms on the other side. Minus 100 plus 4 minus 29 over 2 whole square. I'll put that on a calculator. Okay. Let me check. Okay, so there's a small mistake here. This should be 4y and this should be 25. And that gives me minus 25, y equals to 275 and y equals to 11. Okay, that's 4y. And it says find the coordinates of the point of intersection of the tangent and the circle Q, giving the answer in third form. Third form means in the form of roots. So what was the tangent? 4y equals to minus 3x plus 58. 4y equals to minus 3x plus 58. And circle Q. Circle Q is a little complicated. In any case, we will have to work through it. Let's write 14.5. It makes it easier. Now it's 125 over 4. I think 125 over 4 is 31.25. Let's write that. Now to solve this simultaneously, I will have to make one of these the subject. I can either go on and make x the subject or y the subject. That's my call. So I'm going to just make y the subject and write x squared plus 58 minus 3x over 4 minus 14.5 whole squared equals to 31.25. X squared plus 58 minus 3x 14.5 into 4. Oh, that's also 58. That sort of should simplify my calculations. Okay, so that gives me x squared plus 9x squared equals to 31.9x squared over 16, 31.25. Okay, that was 3x over 4 whole square. I think I've done correct. 9 over 16. 25 over 16x squared equals to 31.25 multiplied by 31.25 divided by answer. That gives me x squared equals to 20. X equals to root of 20, which is 2 root 5. So if x is 2 root 5, then y should be this. Let's see if I calculate again, do this. Even that is fine. I'm just checking if my calculator will give me a better answer. Yes, it says 29 minus 3 root 5 over 2. Yeah, and it should be both plus and minus. Okay, 29 plus minus 3 root 5 over 2. I will have to separate these and say that when x is 2 root 5, y is 29 minus 3 root 5 over 2. And when x is minus 2 root 5, y is 29 plus. Okay, thank you for watching. That is the end of the paper. I will see you with another recording on my channel. Thank you.